Okay, so let's look at number five. So this is a slightly, when I say tricky, I think you actually have to kind of engage with the question a little and try and see what you can do to find your variable cost. So let's draw the graph. So what this is sort of saying is that, okay, listen, when you produce 15,000, at 15,000 units, we see a total cost of 125. So I'm going to start somewhere there and get there. So you have a total cost of 125. Remember that this is all based on this idea of linear trends. I can only really find these high-low method situations if this is a straight line, right? And that's kind of the theory, the underlying theory here. Anyway, it says that, listen, I go all the way to 23,000, and when I get to 23,000, things change a little. Oops, let me just make this straight. When I get to 23,000 units, things change a little. And what changes? It says that the variable cost, um, because I can now do a bulk discount, the variable cost technically changes by 50p per unit on everything we buy um, from here. So because the variable cost changes, you could argue that the slope, because it's not increasing in the same way that's increasing here, it's actually increasing differently going forwards. Maybe it's changed its shape. So so by the time we get to, it's telling us that 24,000 units, you have a total cost of 158,000. Now, I'm just going to change my pen color. So I think probably the easier way to do this is to sort of say, well, because I can only really find gradients based on straight lines, and this question is asking, it says to you, which is why I say you have to sort of get into the question a little. It says, what's the variable cost before the discount? I could sort of argue, well, I know what that discount is. That discount is 50p per unit. So without the discount, this would have cost basically an extra 50p on every unit, right? Because what you have is a discount of 50p. So if you hadn't given the discount, you'd have had a curve that carried on straight line, right? And then you would have had this extra bit here. That's the discount, really. So I can find what that is technically. Remember, all I'm trying to do is to find a variable cost. I'm just trying to find that the shift in that every time I produce one unit, how much does the variable cost increase by? So I can find the situation before the discount. And this amount here is the 24,000 times the 50p, which is equal to 12,000. So in effect, this cost here over here is 158,000 plus 12,000, which takes us to 170,000. So in effect, I can now find, let's change my pen color, I can now find the variable cost using the high-low method because I have that now and I also have that. This is before the discount. So what does that look like? That is 170,000 minus 125,000 divided by 24,000 minus 15,000. So what do I have? 170,000 minus 125,000. And this is 45,000 divided by 24,000 minus 15,000. That's 9,000. And 45 divided by 9,000 is £5. So my variable cost before the discount is £5, right? So, I mean, now that I know the situation here, I can apply this £5 in this scenario because I know that's definitely the case here. Um, so because I mean, the variable cost before the discount applies to the 15,000 units. So what do I have? So I have a total cost, of course, is equal to fixed cost plus variable cost. So I have a total cost of 125,000. And that is equal to a fixed cost plus my variable cost, which is £5 times the 15,000 units. So that's 125,000 is equal to fixed costs plus 75,000, isn't it? Which means my fixed costs are 125,000 minus 75,000, which bring me to 50,000. So I have fixed costs of 50,000. Now, I know that I have a discount of 50p on every unit. So going forward, once I get past this unit, I know that my variable cost after the discount is £4.50, right? So given that you have a fixed cost of 50,000, you know what your fixed costs are. Your fixed cost of 50,000. If it says what is the total cost for 25,000 units, well, with fixed cost of 50,000, given the total cost is equal to fixed cost plus variable cost, the question is asking for total cost. I know what my fixed costs are. My variable cost will be £4.50 times the 25,000. And I have here £4.50 times 25,000. That's 112. This is 112,500. So add the two together because this is your variable cost. So variable cost of 112,500, fixed cost of 50,000. Add the two together, and you have a total cost of 162,500. Yeah, and that's just, and then that's where you go. You have 162,500, and there you are. This is probably, like I said, the easier method. I mean, you could play around with it. You can be slightly more algebraic about it, but that's a bit much. You could sort of find out what's going on here, and then you could sort of argue that you could find out. Some of you, I suspect, might have tried something along those lines. You could give this a letter, call it Z, I don't know, and you could argue that, well, I know that Z minus 125,000 divided by, of course, just this bit, 23,000 minus 15,000. You could sort of wait. You could sort of say, okay, I know that's the situation, but I also know the situation here, right? Is that you have 158,000 minus Z, because really you could sort of find this space divided by this space, but this is just for those who are inclined for this type of thing. 24,000 minus 23,000. So you know that you can find the variable cost here. You can also find the variable cost here, but we know there's a difference. So technically, this minus this is that 50p, right? Because that's what it's saying. It's saying that the variable cost, you get a discount after 23,000. But this is just this point. So if if I was to simplify this a little, just to give me some space here. I mean, this is recorded, so you can go back and see my workings. Um, just to simplify this, if you wanted to, this is sort of saying that Z minus 125,000 over 8,000 minus 158,000 minus Z over 1,000 is equal to 50p. And like I say, you can simplify this, but I wouldn't. I mean, again, like I say, it's just for a different way of thinking about things. So if you find this point, then you could play around and do a few things. But I think this method that I've just done is the easier method. Um, this is all a bit mathy, and you have to start, right? You can make, if you like, the denominator 8,000 and go in there and have Z minus 125,000. Then go is, you multiply all of this by 8, and then you basically work all of the top out, and that's equal to 50p. And you could find Z. You can. Quite feasible, but I would happily go with this method. But I thought I'd just drop this just in case anyone tried this, just to say it is feasible, and you can go all the way and find your answer. Okay, great stuff.